So for question number 1, we're looking in quadrants 1 and 4. What is our angle? What's the angle we're looking for? It has a sine value of square root of 3 over 2. Who got pi over 3? All right, that is the right answer. So remember, sine is your y value. So the angle that has a y value of square root of 3 over 2 is right here. So that is my answer to number 1. Okay, inverse cosine for number 2. For inverse cosine, we're looking in quadrants 1 and 2. So what angle has a cosine of negative root 3 over 2 in quadrants 1 or 2? What's my angle? Who got 5 pi over 6? Okay, so far we're looking pretty good. So that's this right here. So the answer to number 2 is 5 pi over 6. Okay, number 3 is asking 2 questions. So first we're going to answer this question. So tangent, so what is the angle that has a cosine? We're in quadrants 1 or 2. It has a cosine of negative root 2 over 2. So I heard one person say 3 pi. Who agrees that it's 3 pi over 4? The answer to the first angle. So it's 3 pi over 4. And now we're going to answer the second question, which is what is the tangent of that angle? So that's an easy angle for tangent and cotangent. It's either 1 or negative 1. So what do you think your answer is going to be for the tangent of 3 pi over 4? Negative 1. Tangent is negative in quadrant 2. And then lastly, number 4 is cosecant. I always like to write that in terms of sine or cosine. So what this is asking is the inverse sine, and then you take the reciprocal of negative 2. So if you take the reciprocal of negative 2, so that's negative 2 over 1. If you flip negative 2 over 1, what do you get? Negative 1/2. So you're really asking yourself, what is the inverse sine of negative 1/2? That's another way to write that. So if you see secant or cosecant, it might be beneficial to rewrite that in terms of sine or cosine. So I'm back to quadrants 1 or 4 for secant. For cosecant and sine. We're in quadrants 1 and 4. So negative 1/2. So that angle would be here. So that's 11 pi over 6, but we can't write that answer as 11 pi over 6. It has to be between negative 90 and 90. So our answer is negative pi over 6. So just curious, who got at least 3 of those 4 questions right? Okay. If you got 4 out of 4, that's really great, but at least 3 at this point. Okay. So we're going to do just a few more examples. Let me give you a second to copy down our next slide, and then we will talk through them together. Okay, go ahead, copy down these 4 questions. So keeping in mind that when we're looking at our sine and cosine wave, this angle, the value, because this is not an angle, this number here for sine and cosine has to fall, when we're talking about an inverse, so these two, because those two are talking about an inverse, has to fall between negative 1 and 1. Okay, so 2.5 is too high. So there is no angle that has a cosine value of 2.5. So number 1 is D and E, or undefined, but that doesn't exist. Okay, let's look at number 2. So number 2 is asking first for the sine of pi. So this is pi right here. Sine is 0. Okay, so the inverse sine of 0. Now keep in mind, pi is not within my restriction of negative 90 to 90. So first we figured out what the sine of pi was. The sine of pi is 0. The second question is, what angle in quadrants 1 or 4? So now we need to go back over here. So what's going to be my angle that has a sine of 0? 0 degrees. So I'm over here. So the answer is 0. Okay, question number 3. We have to do the Pythagorean Theorem. So what two sides of the right triangle do we use for sine? Is it adjacent, opposite, hypotenuse? Which two sides? Opposite over the hypotenuse. So let's find the adjacent side. So we need to do the Pythagorean Theorem for number 3. Now, first of all, the reason why we can proceed is because 1/5 is less than 1. If this number was greater than 1, then it would be D and E. We would stop, okay? But 1/5 is less than 1. It does fall between negative 1 and 1, so let's do the Pythagorean Theorem. So let's make our right triangle. So 5 is my hypotenuse, and then opposite is 1. Go ahead and use the Pythagorean Theorem to find the adjacent side. So I'm doing it at the top. Remember, 5 has to be your hypotenuse. So 5 has to be C in the Pythagorean Theorem. So that's 25 equals 1 plus A squared. 24 equals A squared. The square root of 24 equals A. So we need to simplify that 24. We're going to split that apart to 4 times 6. So my adjacent side is going to equal 2 root 6. That's my adjacent side. So now that I know my adjacent side is 2 square root of 6, I can tell you the cosine. So what two sides do I use for the cosine of the right triangle? Not opposite. No, that's tangent. Adjacent and hypotenuse, right. So my final answer, because the final end goal is cosine. Okay, so the cosine, my final answer would be adjacent. Let me see, where can I write this? Let me squeeze it. Let me take off some of this. It would be the 2 root 6 over the hypotenuse. And what's the hypotenuse? 5. That's your final answer. Let me go ahead and circle this. That's answer to number 3, number 2, and number 1. So again, let's just talk about it. When it's not on the unit circle, as long as it falls between negative 1 and 1, we can find it using the Pythagorean Theorem, if it's sine or cosine. All right, let's look at number 4. Go ahead, take a moment and see if you can answer that by yourself. Number 4, you need to figure out the sine of 3 pi over 4 and then do the inverse sine of that angle. So number 4 is 2 questions in 1. So take a moment and see if you can answer that one by yourself. So the sine of 3 pi over 4 is what? Is it negative or positive root 2 over 2? Okay. Now, what's the inverse sine of root 2 over 2? Positive or negative? Positive. All right, any questions about that? Kind of clicking in place now. All right, just a few more questions and then we'll do our skills check. So go ahead and copy down these 4 questions. I'm going to, because of time, take off this one. So we'll do those 3 questions. Go ahead, copy down those 3. Okay, so for number one is 2 questions in 1. So the first thing is we need to figure out the cosine, the inverse cosine of 1. So you just got to remember your restrictions. So inverse cosine, that is in quadrants 1 or 2. So what angle in quadrants 1 or 2 has a cosine value of 1? 0. So now we're going to find the secant of 0. So the secant of 0 is what? So 0 degrees is right here. Secant, is that the sister to cosine or the sister to sine? Cosine. So what's the reciprocal of 1? 1. If you take 1 over 1, and you flip it, what do you get? 1. So let's talk about that. 1 can be written as 1 over 1. If you flip 1 over 1, you still get 1. But 0 over 1, that's undefined, or D&E. So if this said cosecant at 0 degrees, then my answer would have been undefined. But it's secant, so the answer is 1. So that's my final answer. So secant is the sister to cosine, and the cosine of 0 degrees is 1, and the reciprocal of 1 is 1. For number 2, this angle is not on our unit circle. So the way we're going to approach this is, because it's sine and inverse sine, is this angle within our restriction? So this is where we have to be a little bit comfortable with fractions, okay? So in other words, do you think pi over 8 is pi over 8 in between negative pi over 2 and positive pi over 2? What do you think? So is the fraction 1/8, is that between negative 1/2 and 1/2? Yes, okay. So because it is, these just cancel out, and my answer is just pi over 8. So my answer is pi over 8 because that's within the restriction. It has to fall within the restriction. So number 3 is just like the one we did before. So square root of 5 over 4 is not on our unit circle, and the square root of 5 over 4 is less than 1, okay? And the way to think about that is, as long as this number is less than 16, this fraction as a whole will be less than 1. Because what is the square root of 16? So 4 divided by 4 would be 1, right? So we just need this number to be less than 16 in order for this to exist. So the square root of 5 over 4 is less than 1. That is less than 1. So because it's less than 1, let's go ahead and make our triangle and find our missing side. So we're going to create our triangle. Sine is opposite over hypotenuse. So the hypotenuse is 4. And opposite is the square root of 5. Let's find our adjacent. So when we find our adjacent side, is hypotenuse, which is 4 squared. That equals the square root of 5 squared plus the adjacent side squared. So this is going to give us 16 equals 5 plus a squared. Subtract 5, you get 11. So your adjacent side is equal to the square root of 11. That's the adjacent. So now we're ready to find the tangent. So what two sides do I use for tangent? Opposite over adjacent. So tangent is equal to opposite over adjacent. So tangent, write that a little bit bigger. Okay, so tangent equals opposite, which is the square root of 5 over the square root of 11. Bring that down a little bit. Tangent equals the square root of 5 over the square root of 11. We can't have a square root in our denominator, so we're going to multiply top and bottom by the square root of 11. So what do you think our final answer is going to be? What's 5 times 11? I know we don't have a calculator. 55. So that stays under the square root. So square root of 55. And then if you multiply two radicals that are the same, so 11 times 11 is 121, but then the square root of 121 is just 11. So our final answer is root 55 over 11 for number 3. And I'll write it over here also. So if you know the 3 sides of your triangle, you can use your ratio, opposite of adjacent. So we could have done that. So if to do it that way, we would have found the cosine and then divided it by sine, and we would have still got the same answer. But if you have a triangle, a right triangle, you know all 3 sides, you can just use opposite over adjacent, and you don't have to divide. Okay? All right, clear off your desk. Let's start our skills check.